is if you have the same base on each side of the equation. So it can only be written once, but if you have like 2 to some power on each side, then those exponents have to be equal. So if you have that set up, you can drop the bases and set the exponents equal. So our strategy is going to be to try to get a common base. We want the same base on each side of the equation, so that then we can just drop that part, set the exponents equal, and solve. So let's start looking at some problems. You guys did these in Algebra 2. We are going to go further with it than you did last year, but today everything we do will probably be pretty similar. So if I give you 3 to the x plus 1 power equals 81. It's not like the problems that we had on the last test where it was like x squared equals 81 and you could add a square root. Here are the variables and the exponent. So we can't just add a radical to get rid of it, but what we can do is get the same base on each side. We're not changing the problem, but I could say, well, 81 is the same thing as 3 to what power? 4. So 3 to the 4th is equal to 81. I haven't changed my problem, but now I have the same base on each side, which says the exponents have to be equal. X to equal 3. And you can always check it just by plugging it into the original. If I put it in 3 to the 3 plus 1 power, I get 3 to the 4th, which is 81, so it should work. These aren't like the radical problems where you get extra answers that don't actually check out. If your math is correct, these answers should work. So if I look at B. 2 to the negative x equals 16. What would you do? Can't change 2 to the negative x, but 16 is 2 to the 4. So negative x is equal to 4, and x is negative 4. Alright. Your base doesn't have to be a whole number. Your base could be a fraction. There are sometimes different ways of solving it, but if I looked at this problem, one fifth to the x equals 1 over 25. What could we do?
Can it do 1/5 squared?
1 over 25 is 1/5 squared. So x is 2. Alright, you guys do D for me. So 4 is 2 squared. So 2x minus 1 equals 2. So 2x is 3 and x is 3 halves. You did pretty well with that one. So those are okay?
It's like, what kind is the rest of them?
Is it an emergency?
Pretty much, yeah.
This one's different.
Huh?
This problem's different.
They're saying I'm different.
Alright, so what would I do here? Can I just write 16 as like 8 squared or something? It's exciting. What would we do here?
like the first one would be like 2 to the third power, but then you have to like put like 3 and then parentheses negative x plus 14.
Perfect. This time we have to change both of them. So 8 is 2 to the third, and he's exactly right. We have to keep that in parentheses because that whole thing is 2 to the negative x plus 14. And 16 is 2 to the 4. All right, here's why those parentheses are so important. When it's a power to a power, what do we do with those exponents? So we get 2 to the negative 3x plus 42 equals 2 to the 4x. So you have to put that 2 cubed in parentheses so that you know to distribute it. Now we have the same base on each side, so we drop it down. 42 equals 7x, and x is 6. Any questions on that? So we might have to change the base on both sides to make it match. Alright, I want you guys to try F for me. So it looks like all of you switched it to a base of 3 and said 27 is 3 to the third. I'm putting that in parentheses because what do we have to do with those exponents? So that's 3 to the 6x. So when you drop them, we have x squared minus 7 equals 6x. This is a quadratic, so we need to set it equal to 0. So if we subtract the 6x, multiply negative 7 and add to negative 6, it would be negative 7 and positive 1. And set each of those to 0, and you get 7 and negative 1. And so we see it is possible to have multiple answers, depending on the problem. Alright. Are these okay? Let's do a more interesting one. Let's take a look at this one. Right. It's different because I have two things over here. Can I just multiply those and say, oh, that's 8x cubed? No. In order to multiply, you have to add the exponents, but that only works if the bases are the same. So I can't multiply my 4 and my 2 yet, but what could I do to those? Okay. We could write them as 2 to a power, right? So 4 would be 2 to the second, and that would still have an x. 2 to the x squared, that's not a problem. 16, how would I write that? You notice I put all those in parentheses because, and now I need to multiply with the exponents that are already there. So that's 2 to the 2x times 2 to the x squared equals 2 to the 8. I cannot drop my exponents yet. The property says the base has to be written once on each side. So before I can drop it, I have to combine these two. My bases are now the same, so I can multiply them together. When you multiply, what do you do with your exponents? Add them. The base doesn't change, but you add your exponents. So now we can set the exponents equal to one another. Subtract our 8. What multiplies negative 8 and adds to positive 2?
How come it's not 4 when you multiply 2 times?
When you multiply, the bases don't change. Just like if you take x squared times x to the third, it's still an x, you just change the power. So the bases don't change here, but you're just adding the exponents together. So how does x squared plus 2x minus 8 factor?
Plus 4 negative 2.
And set those to 0, we get negative 4, positive 2. Is this one okay? Let's try a few more. I think I gave us this one. So my base is E. It's not a nice number, but it doesn't matter. I can't change that. I need to start by looking at this 1 over E squared. What would you change that to? If you want to bring it up, it just has a negative exponent. And so now it's like the last problem. We can't drop the base yet because I still have 2 of them over here, so I have to combine those. Combining them means I add those exponents, so it's 3x minus 2. Now we set the exponents equal. Quadratics, we always get equal to 0, so if we subtract the 3x, add over the 2. Multiply 2 and add to negative 3 would be negative 1, negative 2. You get the x can be 1 or 2. And you can always check these by plugging them into the original. So if you have things multiplied together on the side, you have to get them to the same base and combine their exponents first. Is that okay? Let's take a look at this one. We have to get the same base on each side. What would that be? 5, you could do that. How would you rewrite the cube root of 5? We should all be able. What power would that be, Brent?
Would it be 2 over 3?
Almost. There isn't 2 here, so it's just
Oh, yeah.
1 over 3. So if you have a radical, you can write it as a fraction exponent. How would you write 1/5 if you wanted a base of 5? Mm-hmm. So then you have 5 to the negative 1/3 x equals 5 to the negative x minus 2. Set the x equal. We add the x over. We can divide by 2/3, or you could think of it as multiplying by the reciprocal. So x is -3. Could you have also done that problem by getting a base of 1/5 on each side? Yeah. So it would have just changed your signs. This would have been 1/5 to the negative 1/3, and this would have been 1/5 to the first. So you can go either direction there. All right. I want you guys to try a problem. See if you can figure out this one. There are really several different ways you could start the problem. One option, if you just went into a common base, this is a 2. How would you write 4? We're trying to get the same base. 4 is 2 squared. 1/64 would be 2 to the -6th power. Now some people I think divided the 2 first because it didn't have a variable on the exponent, and you could have done that, then you would have 4 to the 3x equals 1/128, and you could work from there, getting your common base. So there are different strategies you can use. When it's set up like this, these exponents, power to a power, you multiply. What's the exponent on this 2? So when you multiply these together, you add the exponents. So it's 1 plus 6x. So now if you set your exponents equal, 1 plus 6x equals -6. So 6x is -7. And x is -7/6. Does anyone need to look at their paper and figure out where they went wrong? What if I gave us this problem? So we have to get a common base. Can you break 5 down and make it a smaller power? No. So we have to keep that. So that means I need the other side to be 5 to a power, right? So you actually could. Let's talk about that. So he had a different strategy than what I was going to do. So we'll look at it both ways. So he suggested, what if you multiply by 5 on each side? Okay, 1 times 5 is 5. Over here, this is like a 5 to the first. So if you are multiplying those, what do you do with their exponents? Add them. So we get 5 to the 2x. -3 plus 1 is -2. This is like 5 to the first. So then you can set your exponents equal. And that absolutely works. Nice job. If you didn't multiply the 5, and you instead just try to get a common base, how would you rewrite 1 as 5 to some power? 5 to what power equals 1? 0. Anything to the 0 power becomes 1. And so you could write 1 as any base you needed just to the 0 power. And if you work that out, you get the same answer. So 2 different strategies, but both work. All right. Final problem of the day. (1.5 to the x plus 1 equals 27/8 to the x. Alright, so that's a little bit challenging to think about getting a common base when you have decimals and fractions. What could you do?
Would you have to turn the 1.5 into a fraction?
Yes, you would. What is 1.5 in fraction form?
3 times.
Alright, can you write 27/8 as 3/2 to some power?
-3.
I think just +3. A negative would flip it, but. Alright, and then that's still to the x. So we get 3/2 to the x plus 1 equals 3/2 to the 3x. So if we subtract our x and divide x is 1/2. Alright, so if you have decimals, just turn them into fraction form and work from there. Anytime you need to flip something, you do a negative power. So that is our stopping point. There is a handout posted on Google Classroom. And I want you to do the odds. You don't have to do the whole thing, just the odds.